Hello everyone, this is Ankit Shivare. In this module, we will be going to talk on intrinsic semiconductor and extrinsic semiconductor. So intrinsic semiconductor are the group 4 elements where we don't apply any doping. So group 4 elements are like carbon, silicon, germanium, tin, lead. Okay. So silicon and germanium, we have talked earlier about the electronic configuration of silicon and germanium. So these are, silicon is having atomic number of 14, germanium is having atomic number of 32, and we have seen that the valence band is consisted of 3s2 3p2, and germanium the valence band is 4s2 4p2. The extrinsic semiconductor is nothing but when we dope this silicon and germanium with other impurities. Okay, so if suppose we doped with group 5 elements, what are group 5 elements? Nitrogen, phosphorus, arsenic, antimony, bismuth. So phosphorus is 15 atomic number and arsenic is 33 atomic number. So when we dope it with this, so it is termed as N-type semiconductor. And when we doped with group 3 elements, so what are the group 3 elements? Boron, aluminium, gallium, indium, thallium. So when you doped with these impurities, boron is atomic number 5, 13, 31. When you doped with this, so it is termed as P-type semiconductor. So let us go with the conceptual understanding of N-type semiconductor and P-type semiconductor. In N-type semiconductor, we are doping with group 5 elements. Okay. In group 5 elements, we have seen that one electron is extra. Okay. So we generally don't dope very heavily. Okay. So suppose the intrinsic carrier concentration is Ni was 10 to the power of 10 per centimeter cube in case of silicon. Okay. So this is the intrinsic carrier concentration when you have not doped with any other impurities. When you doped with group 5 elements, and how much you doped? You dope like this. Nd, that is the doping that is you are doing, is 10 to the power of 15 per centimeter cube. So this much you dope, then the material is also referred to as extrinsic semiconductor because some extra elements are added. Okay, or extra elements are added. You can also say like that. Okay, so you know this silicon, this having a atom density of 10 to the power of 18 or 10 to the power of 19 per centimeter cube. So this is the atom's density, and in this atom density, this is the number of electrons. That is very less. Okay, you can say this intrinsic semiconductor is very less, and you are doping with 10 to the 15 per centimeter cube. So this is also very small compared to the silicon atoms that are there. Okay, so almost you can say in 10 silicon atoms, or you can say 1000 silicon atoms, there is only one impurity, that is Nd. But you can see, since you have doping with group 5 elements, now one extra electron is coming up to the picture. Okay. And so we can see the extrinsic semiconductor, this will have an electron concentration of 10 to the power of 15 per centimeter cube, which is much greater than this Ni, that is a external intrinsic semiconductor. Okay. Similarly, if suppose we talk of P-type semiconductor, so we doped with group 3 elements. So Na is 10 to the power of suppose 15 or suppose 10 or 14 per centimeter cube we doped. Okay. So this is also referred to as P, that is the whole concentration is P-type semiconductor. So it is P is now 10 to the power 14, that is almost. So this is the doping that we do. Okay. In the next module, we will be talking on the Fermi level diagram and how the electron distributes in the energy states. Thank you.